This is a video on finding the fluid force on a vertical plate. The question states, a right triangular plate with base 3 meters and height 5 meters is submerged in water with its top 1 meter below the surface. The density of the water is 9,800 newtons per cubic meter. Find the fluid force on the plate. So here's our picture. We have a triangular plate. We can see that it's 1 meter below, and the triangle has base 3 and height 5. Let's start out with some basic physics, and that's that the force is equal to the pressure times the area. And next, the pressure is equal to the weight density times the distance from the top of the water, the surface of the water, to the piece of the plate that's having pressure exerted on it. So in particular, our weight density is 9,800 newtons per cubic meter. That's given in the question. Our h is x plus 1. That's because if I take a cross-section right here, nice horizontal cross-section, then I can see that if it is x meters below the top of the triangle, then it'll be x plus 1 meters below the surface of the water. So I set my unit system so that the top of the triangle is equal to 0 meters. Okay, next we find our area. Now, this is not the area of the triangle. This is the area of this small cross-section. And we can think of this cross-section as being a very, very thin rectangle with height delta x and base b. So the area of the rectangular cross-section is b times delta x. Now we've got to find out b in terms of x, and we use the method of similar triangles. We can say that b is to x as 3 is to 5. And then solving for b, we get that b is equal to 3/5 x. We can use that now to get the area. We see that the area is equal to 3/5 x times delta x. I put this fraction into decimal form to make it easier later on and write it as 0.6x times delta x. Now we can look at the force. We could look at the force on this small cross-section, and that's going to be the pressure times the area. The pressure was WH. W is 9,800. H is x plus 1. And then the area was 0.6x delta x. There's our force exerted on the cross-section by the water. Now let's continue, and we can write this as 5880. I multiplied 9,800 by 0.6, and then I multiplied x by x plus 1 to get x squared plus x, and then delta x. So we can say that our total force is going to be the integral of the forces of the cross-sections. We add up all the forces in the cross-section, take a limit as delta x goes to 0, and that will give us a total force on this triangular plate. That's 5,880 times the integral from 0 to 5, because the smallest x gets is 0, and the largest x gets is the bottom of the triangle, which is 5 away from the top, of x squared plus x dx. And I worked that out, and what I ended up getting was 318,500 newtons. And I'm finished with the problem.